I'm going to assume you already know the basics of binary search trees, or BST. Inserting new elements into a standard tree is quite simple. Checking to see if you can find a specific element is also quite trivial. When deleting nodes, there are 3 cases you might run into. In case 1, such as deleting number 10 above, the node has no children, and you can just delete it and set 9's right child to null. It's sad that in this situation, a node disappears and no one seems to care. In case 2, such as deleting 6, I want to delete a node who has 1 child. In this case, I would make the pointer going from that node's parent to that node's child. I guess if the parent dies, the grandparent just steps in. In case 3, such as deleting number 4, it's harder to kill a node that has a lot of descendants. In this case, you move the successor into its spot. In this case, 5 is called the successor at 4. You can also do this process flipping the right and left. 3 is called the predecessor. This is the pseudocode. The transplant function is essentially putting the new root S into where the previous root U was. The first part handles case 1 and the first part of case 2. The second part handles the second half of case 2. It does it one way or another depending on whether the node being deleted has a left or right child. And then all this is for case 3. The tree minimum finds the successor Y, and then you just have to rotate things around. One of the greatest things about using this algorithm is that the runtime never exceeds the order of H, which is the height. A tree traversal is also known as walking the tree. It's going to be pretty cool to call yourself a tree walker. The 3 kinds often used are in order, pre-order, and post-order. For in order, we travel the tree to find each number in order. We go left for as long as we can, followed by going back up and then right. We end up visiting every node in order. It's like in a maze, and keep our hands always on the left wall. We will eventually find our way out. For pre-order, travel the same path except pick up every element the first time we get to it. For post-order, you only visit a node after you have visited both of its children.